In today's lecture, we'll continue our discussion on cloud security in cloud computing. In the previous lecture, we have understood what is security and what are threats, and we have also seen various kind of threat models which are available in the literature. But we discussed in a broader perspective of network security. Today, our discussion will be more focused towards cloud security. More and more organizations are moving their applications and associated data to cloud to reduce the cost and to reduce the operational and maintenance overhead. However, one of the important consideration is that of the security of the data in cloud. And this security is due to two reasons. First is due to outsourced nature of the cloud. Since the data, since the user's data is stored in the data center, which is set up by the cloud provider, that is a third party. So client has a sense of loss of control as data application resources are located with the provider. And the second reason why these security concerns arise is due to resource pooling and multi-tenanted architectures in cloud computing. Moreover, in cloud, client heavily depends on the provider for resource allocation, identity management and authentication, data and service security, and monitoring and repairing of services and resources. Therefore, one of the major concerns of the users before moving to the cloud is the security of their data, more so if the data is sensitive. Cloud computing brings new threats such as multiple independent users share the same infrastructure, same physical infrastructure. This is multi-tenancy. Therefore, an attacker can legitimately be in the same physical machine as the target. So since the basic essence of cloud computing is that there is a physical infrastructure which the cloud provider has, and he hosts multiple virtual machines on that, and each of these virtual machine is given to an independent user. Therefore, multiple users are sharing the same physical infrastructure. Therefore, it might be possible that one of these virtual machines is an attacker and wants to access the data of another user who is on, though on an isolated virtual machine, but on the same physical infrastructure. Multi-tenancy, although is not an essential characteristics of cloud as listed by NIST. So the 5 essential characteristics which the NIST has listed, multi-tenancy is not in those 5. However, CSA has identified multi-tenancy as an important element of cloud computing. CSA is Cloud Security Alliance. Multi-tenancy in its simplest form implies the use of same resources or application by multiple consumers that may belong to same or different organization. So multi-tenancy in a way, though it is a very essential and important element of cloud computing, but also brings along with itself security issues. Let us look at these diagrams. So this is a private cloud. So it is a private cloud of company XYZ with 3 business units. Each has a different security and service level agreement. So in this, business unit A has 3 virtual machines. Out of these 3 virtual machines, one of the virtual machine is hosted along with virtual machine of business unit B on the same physical infrastructure. Though these 2 virtual machine of business A are completely isolated, similarly business unit C has 2 virtual machine which are completely isolated and are hosted on an independent physical infrastructure. However, these 2 virtual machines, that is one virtual machine of business unit A and one virtual machine of business unit B, they share the same physical infrastructure, that is, and they are interacting with the same virtual machine monitor. Similarly, this is a public cloud scenario. In this, there are multiple customers. If we observe here, customer A and customer B, their virtual machines are again hosted on the same physical infrastructure, and they are interacting with the same virtual machine monitor. Now, the issue here is in this case, both in public and private cloud, virtual machine monitor can be compromised, or one of the units can introduce certain bug in the host such that it can access the data of other unit. So therefore, though multi-tenancy allows better utilization of the physical hardware infrastructure, it also brings along with itself security threats which must be tackled. So before we proceed, understanding the relationships and dependencies between cloud computing models is critical to understanding cloud computing security risks. So if we look at the model of service model of cloud computing, there are three layers. The bottommost layer is IaaS layer, which is the infrastructure as a service layer. On top of that builds platform as a service layer, and on top of PaaS builds software as a service layer, that is SaaS. So the point is that the capabilities are inherited from one stack to another. So are information security issues and risks. So commercial cloud providers may not exactly fit into the layered service model. However, this kind of model is important for relating real world services to an architectural framework and understanding that resources and services require security analysis. So let us look at this model. So we know that there are three services, and infrastructure as a service is the broadest service. Then is platform as a service, and on top of that is software as a service. So for the sake of completeness, their definitions and examples are listed here as a recap. From the security point of view, the customer security responsibility increases as they opt services from software as a service to infrastructure as a service. If a customer is opting software as a service, then the entire security responsibility is on the provider side. The customer's responsibility for security increases as he opts for platform as a service, and in infrastructure as a service, the customer has the maximum responsibility, security responsibility as compared to the provider. Next, let us look at threats in cloud computing. There are 9 threats which have been listed by Cloud Security Alliance. So these are the 9 threats. So this is based on the research conducted by CSA. So these 9 threats are: first one is the data breach. This is the number one security threat for cloud computing. Second is data loss. Third threat is account or service traffic hijacking. Fourth is insecure interface and application program interfaces. Fifth is denial of service. Sixth is malicious insider. Seventh is abuse of cloud service. Eighth is insufficient due diligence. And finally, ninth is shared technology vulnerabilities. So let us discuss these in detail. Data breach. So data breach is the security threat where data is accessed by unauthorized user. So basically it refers to the loss of confidentiality for data stored within a particular cloud instance. Such a threat is likely to exist even within an on-premise solution or traditional outsourced solution. The loss of confidentiality for an organization can have significant impact regardless of whether the data are hosted externally or are on an internal provision service. So let us look at the types of data breach. First is intellectual property. So this deals with loss of intellectual property and confidential business information. Some sectors, finance, chemicals, aerospace, energy, defense, and IT are more likely to be targeted and face attacks that persist until they succeed. Next is financial crime. So financial crime usually involves fraud, and it is about exploiting the consumers, banks, and government agencies. So, the most damaging financial crime seeks to penetrate bank networks, with cyber criminals gaining access to accounts and siphoning money. So, these targets are not solely targeted at cloud computing. Third major threat is confidential business information. The theft of confidential business information is the third largest cost from cybercrime and cyber espionage. So, in this, the business confidential information can be turned into immediate gain. Uh, the loss of investment information or exploring data and sensitive commercial negotiation data, that this can be used immediately. So the damage to the individual company runs into millions of dollars. So to sum up, whether an organization is research R&D organization, R&D sector of the industries, or big universities, who are really bothered about the intellectual property, or it's the banks and the government agencies dealing with finances, or it is the big business houses where their data is extremely important. All of these will be affected if the data leak occurs, that is, the data breach happens. So, data breach, therefore, is the number one threat listed by CSA. Second threat is data loss. Basically, data loss refers to unavailability of the stored data within the cloud for end consumers. And there can be many reasons for this. First is provider gets bankrupt. Recognizing the impact of a provider going bankrupt has led to introduction of legislation that allows the end consumer a legal right to claim back data from a bankrupt provider. So, if a provider, declares that it has gone bankrupt and closes the service, so the user has a right to get back the data which is stored in those data centers of the provider. So, the bankrupt company must not be a legal owner of the data, but must only hold it. The claimant must have entrusted the data to the bankrupt company or be the legal owner of the data. The data must be separable from other tangible and non-fungible movable assets of the company at the time of opening of bankruptcy proceedings. So basically, the first reason for data loss can be a provider gets bankrupt and he has declared that the data center is no more operational because it is bankrupt and will be sold out. So at that time, the user has full right to claim the data. Second, providers do not follow service level agreement regarding the availability. In the SLA, there is a clause which says that data will be available, let's say 99.99% of the time. So, and this SLA should not be violated. So, if provider does not violating this SLA due to several reasons, maybe due to network problem or due to electricity problem, then also the user experiences data loss. Third reason for data loss is error. It could be as simple as a human error. That is, by chance, let's say the operator deleted something. So, this also leads to unavailability of the data to the end customer. Third threat in cloud computing, as listed by CSA, is account or service hijacking. So basically, account or service hijacking is due to the identity theft, and it is carried out by an attacker to steal the information of person or an organization. So the information can be gathered by the attacker using malicious software, phishing, or information may be leaked by the carelessness of the user. So this can also happen due to insecure interface and application program interface. So APIs within cloud environment are used to offer end customer software interfaces to interact with the provisioned services. So basically, we have a service and we have a user. The interface between them is called as application program interface. If this interface is insecure, then a third user can access the data. So there are multitudes of APIs available within a cloud environment. These include provisioning new hardware and monitoring the cloud services. Insecure interfaces and APIs can be exploited for hijacking cloud service. Next is denial of service. So denial of service, we understand it is basically, it refers to flooding the network or the infrastructure with unwarranted data, unwarranted traffic, so that the user cannot access the particular resource. So it refers to an attack that aims to overwhelm the victim with the network traffic or consuming resource. So this consuming resource, it can be either CPU, memory, um, and subsequently prevent the processing of the legitimate request. So infrastructure based attack, they reside either in the network layer or in the transport layer, and in this the attackers, they overwhelm the target such that it cannot respond to any other request. Second type of DOS attack is application based attack. So unlike the use of traditional infrastructure based distributed denial of service attack, the emerging trend has been to for using layer 7 attack. Layer 7 is the application based attack. So basically it means that rather than using the network traffic to overwhelm the target, it would use the traffic that appears legitimate. So an example here is in McAfee report, which is entitled Cybercrime Exposed. It is mentioned that such denial of services are accessible to anybody with access to a search engine, which costs as little as $2. That means user can purchase a denial of service attack for a $2. Therefore, the probability of such attacks occurring are increasing. Fifth threat, which is listed by CSA, is malicious insider. Now, within a cloud computing environment, there are three types of cloud-related internal threats based upon the CERT program, Software Engineering Institute, Carnegie Mellon University. So they have classified this malicious insider into three classes. First, they say, is the rogue administrator. So rogue administrator, that means the hosting company administrator. So he has the highest level of access and therefore can cause the greatest impact, such as updating the drivers of the virtual machine to compromise the images. So basically, a rogue administrator is the person who is working with that cloud provider company, and therefore he has the access to the entire physical infrastructure and the software controlling it. So therefore, such a malicious insider can potentially cause a lot of harm to the user. Second is virtual image administrator. So virtual image administrator could create alternate images outside the authorized baseline, and that report they align with such a baseline. So what a virtual administrator, image administrator can do, it can completely copy or steal the virtual image of a virtual machine and copy it somewhere else. It could create an alternate image of the virtual machine. So that means the entire data, everything, copy has been made and has been stolen. Next is system administrators. So system administrators have the ability to conduct operating system attack, and they could update the virtual machine drivers to the vulnerable instances. So if so basically in all of these, if you see, either the virtual machine drivers are being compromised, or the virtual machine monitor is being compromised, or a complete image of the virtual machine is being made and is being copied somewhere else. So this can happen if there is a malicious insider. Sixth is exploit a weakness introduced by the use of cloud, and such weaknesses can be exploited by malicious insiders. So an example of such a kind of weakness is that is the difference between the access control model between the local system and a cloud-based system. Access control is a very important thing. Access control means which user gets to transmit. So if there is a difference between the access control model which is being followed by the local system and the one which is being followed by the cloud-based system, then of course the data intended for the user can be directed somewhere else. Then is the abuse of cloud service. The abuse of cloud service extends beyond the malicious insider and potentially allow cyber criminals the ability to utilize such services for criminal gains. For example, cracking the passwords. So in particular, using the computing resource to undertake a brute force attack. Uh, so what is a brute force attack? Brute force attack is basically brute force method means trying all possible combinations. So let us take an example. If there's a password which is let's say a 6-digit long, and let's say it is using just numbers. So that means it can have the possible space from which those 6 spaces can be filled is from 0 to 9, uh, that is 10. So that means the possible combination of password will be 10 raised to 6. Though it might seem to be a large number, but trying out 10 raised to 6 password will be, this job in cloud computing environment will be completed within seconds. So this actually is a brute force attack. So therefore, users are told to make a very strong password which has combination of numbers and alphabets and special characters, also uppercase, lowercase. So this is just to increase the space of the password. So where that is the now if the if the cracking of the password requires searching of a wider space compared to the example we just took. So there have been many demonstrations highlighting the use of cloud computing to brute force password. That is, attacking, trying to crack the password by trying all possible combinations. So this is one of the examples of abuse of cloud service. So eighth threat is due diligence. It is a process of evaluating cloud vendors and in some cases internal procedures and resources to ensure that business objectives are met and the company's interests are protected. So in a case of selecting a cloud computing provider, due diligence entails investigating the potential cloud providers to understand how they implement best practices, protect their customers' assets, and meet the scope of the user's requirement. So basically, due diligence it must be applied while selecting a cloud provider. If the user is entrusting a particular cloud provider with its data and sensitive data, then the user must in detail, understand about the different policies of how their data will be protected in the data center which is owned by the cloud provider. Finally, the last threat is shared technology vulnerability. So one of the many benefits of cloud computing is ability to leverage economies of scale by sharing resources across multiple customers. However, this also brings in a threat along with itself. For example, the type of risks associated with this category includes failure of mechanism associated with storage memory, routing, and even reputation between different tenants of shared infrastructure. So this is example so-called guest hopping attack or SQL injected attack exposing multiple customers' data stored in the same table and side channel attack. So in guest hopping attack, an attacker will try to identify two virtual machines likely to be hosted on the same physical hardware. And assuming that attacker is interested in data from virtual machine A but is unable to directly penetrate virtual machine A, then attacker will try to penetrate virtual machine B and then try to gain the access of the virtual machine A. So this results from shared technology vulnerability. Let us see some additional cloud threats. First is loss of governance. Because now the user is not has basically handed over the control to the cloud service provider. Next is lock-in. So this is a very important point to discuss. So in lock-in, what happens? If a user has chosen a particular cloud provider, and the user wants to expand the data, let us say that not within this cloud provider and somewhere else, because maybe possible that this cloud provider where the user currently is offering the escalate if is offering the scaling of the service at a much higher cost, or maybe the resources are not available, or due to any reason. But what happens is now the user is not able to migrate from the cloud provider to another cloud provider. That is because the service which is being provided by this cloud provider is either dependent on the technology or the hardware, or maybe there might be several other reasons. So basically, lock-in is where it becomes difficult for the end customer to migrate from their cloud provider, and this might be due to various reasons. Isolation failure. This is related to the risk of failure in mechanisms that are intended to separate storage, memory, routing, and even reputation between different tenants. Next is compliance risk. So migration to the cloud may result in compliance failure for potential cloud customer. For example, migration of personally identifiable data outside the specific region. So, what is compliance risk? For example, if the banks in India, they would like that if they are taking service from a cloud provider, physically the data center should be located in the Indian subcontinent. It should not be, located, let's say, in Nepal or, neighboring country where there are other risks. So, this is the compliance risk. And finally, the last one is management interface compromise. So as the interface to the cloud service is through internet, um, and the provider accesses to a large set of resources, therefore this risk is huge. So basically, the entire cloud computing services, they are being offered through internet. Uh, there is data of n number of users which is flowing in the same channel or the same pipe, that is the link. So therefore, this interface, the risk of attack increases multifolds because it is through an open internet through which the service is being provided. Okay, so with this, we'll conclude this lecture today. What we saw in this lecture is the threats in cloud computing. We saw that the threats in cloud computing, the security concern is due to the outsourcing nature of the cloud, and also due to the multi-tenanted architecture. And then we saw the 9 threats which have been listed by CSA as the major threats. We'll continue our discussion on cloud security in the next class. Thank you.